at the interval. Like, where does it start and stop? We know when we graph tangent, we typically go from negative pi over 2 to positive pi over 2. When we graph cotangent, we go from 0 to pi. So look at, are you starting at 0 or is it starting at a negative value? Negative 0.5 pi, that's just another way of writing negative pi over 2 to positive pi over 2. So which one is this? Tangent. All right, my amplitude. It's not really a true amplitude, but I'm looking at these middle points. Where are they at? 3. So this has to be a 3 tangent. If I went from negative pi over 2 to positive pi over 2, that's the normal period, the normal section we graph for tangent, so it's just 3 tangent of x. If I look at b, first we have to decide, is it tangent or cotangent? Cotangent, and we know that because it goes from 0 on. So we're looking at a cotangent graph. Mine has done a couple things here. If you look, the center, it's actually centered at 1. Okay, my amplitude, how far, bless you, above and below that center do we go? We just go 1, so it's just a 1 cotangent. Okay, what would cause this graph to move up 1? Okay, so we have a +1 on the end. Does cotangent normally increase or decrease? Decrease. So what would cause it to flip like that? Okay, so we have a negative cotangent. All right, we know the normal period for cotangent is pi, right? But how long did it take before this one repeated? 2 pi. So that meant when we did pi divided by the number in front of x, we got 2 pi for the answer. If I multiply over my b and divide by 2 pi, we get 1/2. So it's a negative cotangent of 1/2 x plus 1. All right, so tangent and cotangent are kind of the weird ones. They have a shorter period of pi. We have to pick some different intervals to make asymptotes happen nicely. Secant and cosecant are actually really nice because we're already really good at the graphs of sine and cosine. So let's talk about cosecant for a minute. That's the first one I have on your notes here now, right? Okay. So cosecant is the reciprocal of what? Sine. Okay, what's the sine of 0? 0. So cosecant would be undefined. All right, what's the sine of pi over 2, or 90 degrees? Yeah, or you can make back here. Remember, sine is the y. So sine is 1, so the reciprocal is 1. Okay, at pi, what's the sine of pi? 0, so cosecant would be, all right, 3 pi over 2. Sine of 3 pi over 2 is -1, so cosecant is -1. 2 pi, you're back to the beginning. Sine is 0, so cosecant is undefined. All right, so we're back to the points that we were a little more used to on the x-axis. Pi over 2, pi, 3 pi over 2, and 2 pi. All right, and what we have, undefined, which means what on the graph? Okay, pi over 2 is 1. Pi is undefined. 3 pi over 2 is -1. And 2 pi is undefined. Kind of hard to really tell what's going on there. We know, like at pi over 6, 30 degrees. What's the sine of 30? 1 over 2. So cosecant would be 2. Right? Same thing when I did the 5 pi over 6. Sine of 5 pi over 6 is also 1/2, so cosecant would be 2. Do we have a better idea of what's happening here? Yeah, and when we did it over here, in quadrant 3, it would be a negative. Quadrant 4, it's negative. And so what we're getting is these little parabolas. So it's like an upward and a downward facing parabola. Now, why I said this is really easy if you already know the graph of sine, let's talk about sine for a minute. Where does sine start? 0. And at pi over 2, sine is 1. Pi, it's back to 0. 3 pi over 2 is -1. And 2 pi, it's back to 0. So anywhere sine was 0, what did we get on our graph? An undefined. And the high and low points stayed, and then we just turned the graph away from the axis. Okay, let's see if that reasoning would work for secant. Let's graph secant is the reciprocal of cosine. So if I graph cosine, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, I just want you to lightly draw this in because this isn't the final graph we're looking for. It's just cosine. What's the cosine of 0? 1. All right, remember our cosine graph went 1, 0, -1, 0, 1. So this is my cosine graph. So based off that, where should I have asymptotes? If I keep my high and low points like I did on sine, and it's a reciprocal, so it's just turning it away from the x-axis. So this is like half a parabola going up. Here I have a parabola going down. Here I have a parabola going up. And if we check our points, okay, at 0, cosine's 1, so secant's 1. At pi over 2, cosine is 0, so secant's undefined. At pi, cosine's -1, so secant's -1. 3 pi over 2, cosine is 0, so secant's undefined. And 2 pi, we're back to being 1. So these points match up. So when we graph these, we are actually just going to graph sine or cosine, which we're already really good at. And then we will use that to figure out where the asymptotes go and flip the graph away from the x-axis. Last thing I want to mention on these, even or odd. So this one, if I reflect it over the or the y-axis, remember the pattern's going to continue, so it's just going to be a downward parabola. So if I flip it over the y, would it overlap? No. If I flip it over the origin, the y and then the x, would it? Yeah, I would have, if I flip it over the y, it'd be up here and then down here. So cosecant is another odd function. So that means if you have a negative on the angle, you can take it out in front. What other functions are odd? All of them except cosine. Cosecant, sine, tangent, cotangent. Those are all odd. Cosine was the only even function. If I think about secant, if I flip it over the y-axis, would it overlap itself? Yes. So secant and cosine are the only even ones because they are reciprocals, which means on those, if you have a negative on the angle, you can just drop it. Okay? So that's all I wanted to get down today. I just wanted those basic graphs, and then we'll practice them tomorrow. So whatever time is remaining, you can finish your homework.